Hey there, so for this example 13, the figure shows part of the curve. We've now got a relation, not a function. We've got x equals 6 times y minus y squared, and part of the line y equals x, which is the one shown in red there. So find the coordinates of A and B. Okay, so we want to find coordinates A, which looks like it's just the y-intercept, and then the intercept between y equals x line with x minus y squared is from what I can see there. Okay, so from here, let's see. We want to find A. A is probably going to be easier to find. So A is the y-intercept. So that's when x is equal to 0, so you need to find the y value. So in our relation, we've got x is equal to 0 and 6y minus y squared is the equation. From here, looks like we're going to solve it by factorizing. So take y as a common factor, so 6 minus y, and that would then mean y could either equal to 0 or 6. Okay, so that means that if it could be, y, yeah, so y could either equal to 0 or 6, which we can see that there is a point down here where there's also another intercept, so y can be 0 when x is 0. So we've got 0, 0, and over here we've got then 0, 6. So I now know, therefore, A must be 0, 6. All right, well then now I need B. So B, for the point B, looks like I'm going to be solving for the equation, so these two equations. And to solve it, it looks like it's easier if I just, since x equals to y or y equals to x, we can then say for B, we're going to solve. So we don't know what the xy coordinate is, but we do know that it is the intersection between y equals x and x equals to 6y minus y squared. So using substitution method, we can say substitute x equals y to that, and that gives me y equals to 6y minus y squared. But looks like then 0 is equal to 5y minus y squared. Let's see what I can do here. So factorize it, y 5 minus y. So therefore y is either equal to 0 or 5, it seems. So, all right, so that tells me that this point must then be 5. The y value is 5, and to find out the x value, I'll have to substitute it back into the equation. It says here x is equal to, so since y has to be 5, x is equal to 6 times 5 minus 5 squared. What's that? 30 minus 25, so that equals to 5. So it tells me, therefore, B must be at 5, 5. Okay, so now I've got the coordinates of A and B. So I've got 5, 5. So it looks like we can think of it as this is 5 and this is 6. Cool. All right, what's part B? Part B, find the area of region P. Okay, so I want to find the region P, which is from here to here. Now, traditionally, it seems like what you normally would do is to find P, you would find the area under this part of the curve. Okay, so then it will give you this entire region. And then you would then minus the area under the red curve, which is this one here, between this point and this point. Now, since we know this is 5, so it's between 0 and 5. That's what we probably usually do, but I can already see a problem here. Because this is written in a relation form, which is x equals to 6y minus y squared, it means that if I want to solve it with the x-axis, so normally when you integrate it, it's with respect to x, so hence why you go from 0 to 5, and then you'd now need to rearrange this equation, but can you see there's a problem? If you rearrange this into a function, it's from a quadratic relation to the y-axis, it will end up being a plus or minus square root relation, which makes it really hard to integrate, whilst quadratics is much easier to integrate. So I probably won't even try to do that. I'm not going to do it with respect to the x-axis. I'm probably going to try it with the respect to the y-axis instead, because the which is from 0 to 6 will tell me that point. Okay, so from 0 to 6, I want to do 0 to 6 integration of 6y minus y squared delta y. Okay, that would be easy because I know how to integrate polynomials. So your question, yes, that is correct. Do we just integrate in terms? Yes, we do, but be mindful because if you kind of switch your head around or turn your head around and have a look at it, this is essentially from, I'm just drawing it from this way, 0 to 6 was this way, but notice that somewhere along the line, which is here, this is where 5 is. If we were to integrate with respect to the y-axis, then when you integrate just the function itself, you'll get the area under this curve, which is from here to here. True, but because you want region P, now I need the area under the line curve, which is from 0 to 5. Okay, so you actually have to split that interval into two sections here. You would say that it is from 0 to 5. You are now integrating the y equals x line. So that gives you the area with respect to x, with respect to y. So remember, this is what I'm trying to say. I'm trying to say find out this area between 0 to 5. So from here to here first. Okay, and then you can then find the next section, which is the area under the curve from 5 to 6. So this is delta y plus, you need then from 5 to 6 of 6y minus y squared delta y. Okay, so that's essentially how you would do it. So yes, you are correct. That's what you would do, but you need to split the interval into two sections in order to do that. But how does that work and affect the actual area we are solving? So it'll affect it because you have to split it into two intervals. Otherwise, if you didn't split it into two intervals and you just integrated from 0 to 6, right? If you just went straight doing that, what you're actually doing is you're going from 0 to 6, find the area under this curve, which means you're finding this entire region, which is not what you want. Okay, so you're actually trying to find the region for P. So remember, P was part of the section which is only from here to here. That's why we have to split it up into two regions. Okay, because there are two functions that it runs on the interval on your y-axis. 5 to 6 is part of a function, and then 0 to 5 is another set of functions. Okay, so once you understand that, then part B, to answer the question, in part B, you've modeled it now. We know that to integrate 0 to 6 of 6y minus y squared, which is what you would have wanted, but remember, technically it's not. You're not getting the whole entire region, so that's why we're now splitting it into 0, 5, just y delta y. So technically, I should probably say this is region P. Okay, so probably shouldn't have said equals. That's not true. Okay, so region P would then equal to 0 to 5 y delta y plus from 5 to 6 of y, 6y minus y squared delta y. In this case here, this is much easier to solve because we know how to integrate y. So integrating y would then be half y squared from 0 to 5. Okay, and then you've got over here, this is from 5 to 6, that would be what, add 2, so that's 3y squared minus 1/3 y cubed. Okay, and then here we go, that's solving the part, so we're going to substitute the values in. 5 substitutes 25 on 2 minus 0, so it's 25 on 2, plus, let's say, I'm going to substitute 6 in first. 6, so I'll probably have to use a calculator here. All right, what was it? 6 squared, so 6, what is it coming up? 6 squared times 3. minus 1/3 times 6 to the power of 3, which is 36. Is that right? Let's see. It seems like I did something wrong. What have I done wrong already? No. Let's just assume it is 36. So it's 36, that region, and then I'm going to substitute 5 in. So what? 3 times 5 squared, so 3 times 5 squared minus 1/3 times 5 cubed. So 100 and, wow. I don't think I've done anything wrong, have I? No, I don't think so. So if I did this and I changed it to 6, and then I changed this to 6, no, still the same. All right. So then what's 36 minus 8 on 3? This feels a bit funny. So let's just say that's plus 8 on 3 once we calculate that region. And then 25 on 2 plus 8/3. So it should be 91 on 6. There we go. Cool. So I cheated there, just because it went into cubes and it's 6. So I just kind of gave up there. But yes, you can technically do that by hand. It will just take a bit longer to do. But yeah, there you go. So this is your region for that, plus this region here together is 91 on 6. That's your area region, so units, squared units. Okay, there you go. And then what is part C? Find the area of region Q. So in this case now, so region Q, you can see that region Q would be based on the fact that you can now, since you know P, see you can find the area, what you were saying before, which was here. That would be from 0 to 6. You find the entire region minus the area from P, and that's how you're going to get area Q. Okay, so if you were to set it up, it would be integration of 6y minus y squared delta y, and you're going from 0 to 6, so that gives you the full area of this region here. But we know that from 0 to 5, okay, so 0 to 5 was already, we already calculated that, and then we had from 5 to 6, we already calculated these two regions here is P, so that's region P there, that's P, and to find Q, if I just found the area of red minus the area of green, I should be able to get Q. So here I would then say minus region P. So region P in this case was 91 on 6. Okay, and then all you have to figure out is this one. Okay, and what would that be? That would essentially be the same thing as before, except now it is from, what's that? 3y squared minus 1/3 y cubed. Zeros will cancel them out, so it's just 6. And from memory, wasn't that, you got a, I think that was 36, wasn't it? Yeah. So then it's 36 minus 91 on 6, so 36 minus 91 on 6, and I'm going to cheat again. 36 minus that, 125 on 6. There you go. So that's how you would answer this question here. It's a pretty nice one, typical exam question where they get you to integrate with respect to the y-axis. You can do it this way, but man, we don't know how to do integration of surds. So you had to, by whatever skills you currently have at the moment, you should have done it with the y-axis, and that's how you would do it. Okay.